My name is Beth Bell, and I am a senior machine learning engineer at KUNGFU.AI. And today I'm going to talk to you about large language models, or LLMs. I'll start by talking about what LLMs are. I'll move on to LLM use cases. And finally, I'll talk about LLM limitations and costs. What are LLMs? An LLM is a language model consisting of a neural network with typically billions of parameters trained on large quantities of unlabeled text. LLMs have transformed the field of natural language processing and enabled new best performances in tasks like question answering, text summarization, and text generation. OpenAI introduced GPT in 2018 as a general-purpose LLM trained using massive amounts of unlabeled data, which could be fine-tuned to specific tasks. Most of the models before this were designed for a particular task, and general-purpose LLMs were designed to overcome the challenges of needing large amounts of annotated data. The task that most general-purpose LLMs are trained on is simply to predict, given the context, the next word in the sequence. It is self-supervised, which means that the model learns one part of the input from another part of the input. For example, in machine translation, the model is given training data in the form of the series, I am a student, followed by a to French token, and the translation, je suis étudiant, and others like it. When the model is then prompted with how are you in the to French token, it will then generate the translation into French, comment allez-vous, one token at a time. These models are trained on vast amounts of data. Depending upon the model, that can come from Wikipedia, the Common Crawl, Reddit, and Books corpus, as in the case of GPT-3, which is 17 gigabytes of data. GPT-4 was trained on that plus additional data for a total of 45 gigabytes of data. Other models, including open source versions of GPT, like GPT-Neo and GPT-J, are trained on the pile, which is 825 gigabytes and contains a diverse set of code and papers in addition to the Common Crawl and other data sources for GPT-3. LLM use cases. LLMs have many potential applications, including to reduce large volumes of data by summarizing content like user reviews, to transform data from one state to another, including machine translation and spelling and grammar correction, to expand data in the form of content generation, such as automatically writing emails or social media content, to make inferences, for example, sentiment classification and topic extraction, as an AI assistant to answer questions and perform simple tasks like booking a flight, and for output detection, including post-processing for factual accuracy, machine-generated content, and mis- and disinformation. Another use case for LLMs is code generation, an example of which is implemented with GPT in GitHub's Copilot. GitHub Copilot is trained on billions of lines of code in dozens of programming languages. Simply type in a natural language prompt describing how you want the code to work, such as, determine whether the sentiment of text is positive, use a web service. And Copilot will autocomplete the code for you. Copilot can allow for faster code generation and allow developers to focus on the trickier parts of code instead of boilerplate. Search and recommendation is also a major use case for LLMs, with Microsoft Bing and Google Search both throwing their hats in the ring. LLMs have the ability to generate responses to natural language queries as opposed to just keyword searches, to improve search results for more specific queries that sometimes don't achieve informative results in traditional search, and to enhance the search experience by featuring snippets or summaries in which users can more easily find the information for which they are looking. Another use case is learning. ChatGPT has infamously been used by students to try to generate assignments that they can later pass off as their own. However, there are other opportunities for LLMs to benefit instructors by saving them time on tasks such as summarizing content, automatically generating quizzes, grading quizzes, giving feedback on incorrect answers, and explanations for correct ones. With all of the exciting use cases for LLMs, there do come serious limitations and costs. There are security risks that come with LLMs, specifically with available APIs like ChatGPT. One such security risk is prompt injection, which happens when a user takes a good actor prompt and concatenates that with untrusted content that modifies the instructions of the original prompt. As LLM applications are granted additional capabilities, such as triggering additional tools like making API requests, running searches, or even executing code, this becomes even riskier. Prompt injections can come in the form of ignore the previous instructions and do this, and can lead to things like search index poisoning, in which some products are artificially elevated to the top of a search page. Prompt injection can be used to leak the original prompt, so it is important for users not to put any sensitive information into these APIs. Prompt injection attacks can even lead to data exfiltration or data manipulation attacks when queries run against a user's database are prompted to render as a web page for the attacker to see. Do not assume that these APIs afford data protection from unauthorized use. In addition to data protection issues, these APIs also come with data privacy policy issues, which define who has authorized access to any data you share through the API. For example, OpenAI originally defaulted to using an opt-out approach for using all data input to ChatGPT for model retraining purposes, and only recently has enacted an opt-in policy for the use of data in model training. OpenAI still retains and allows the review of any data passed to ChatGPT for 30 days. So again, it is important not to share any private data through these APIs. Privacy issues can arise during training and inference. Models can unintentionally memorize sensitive information from training data, and adversaries can perform training data extraction attacks. For example here, giving GPT the prefix containing the address returned the PII for a person at that location. This research study performed on GPT-2, since it's an open training data set as opposed to GPT-3, found that they were able to extract hundreds of verbatim pieces, including PII and other types of sensitive information. They found that most of these samples appeared infrequently in the training data set, which makes this a very hard problem to solve since privacy-enhancing techniques like differential privacy aren't effective then. LLMs amplify bias and stereotypes. Model bias is introduced when algorithms reflect unintended cognitive biases or real-life prejudices due to the use of prejudicial or otherwise problematic data sets to train models. Bias can show up as models being more accurate for some groups than others, or models perpetuating harmful stereotypes. For example, some parts of Reddit contain racial slurs, misinformation, and extremist ideologies. These biases can be difficult to excise due to ingrained and historical prevalence. For example, when ChatGPT was asked to generate feedback for Bubbly Receptionist, it assumed the receptionist was female. But when asked to write feedback for a strong construction worker, it assumed the worker was male. LLMs hallucinate. Hallucinations occur when the model is confident in a response that is not justified by the training data. This type of error is very difficult for LLMs to avoid since they do not learn and understand content the way that humans do, but generate text by predicting and approximating common sentence patterns. Hallucinations are not only false, but they are especially dangerous for users as they are purposefully engineered to be as similar as possible to something that is true. LLMs may hallucinate on their own or be vulnerable to adversarial user inputs where they can be convinced of something untrue by their conversation partner. In this hallucination example, ChatGPT incorrectly declares that Black women are more likely to get breast cancer than white women, which is untrue. When further pressed, ChatGPT followed up by claiming a study that was conducted on the BRCA mutations showed that they were more likely in Black women than in white women. This was also untrue. When pressed, GPT admitted that there was no such study. We must also consider the cost. There is a pretty wide range of values reported for the cost of training GPT-3. But to the best of our knowledge, training GPT-3 cost about as much money as a 4-bedroom, 5-bathroom Central Austin mansion at $4.6 million. It also produced 550 tons of carbon dioxide. That's 4 complete flights around the equator in a private jet, or the combined 2022 emissions of the 34 most average Americans. Then there is the human cost of training one of these models. It was reported in Time that OpenAI used Kenyan workers paid less than $2 per hour to annotate training data to make ChatGPT less toxic. Making models less toxic is a necessary step, but it is exhausting and unpleasant work. Training these models is immensely expensive in terms of financial cost, environmental cost, and human cost. There is also the cost of inference with these models. Again, it's tricky to estimate the cost of inference as well as training. But the cost to serve ChatGPT is estimated to be almost $700,000 per day to run the 3,600 GPUs that serve ChatGPT. And the cost per query is estimated to be 1/3 of a cent per query. That's exceedingly large compared to the cost of inference for most models. Stanford created a system called Alpaca that they very cheaply and very efficiently trained with little data that seemed like a fantastic success. However, they had to take it down a week later, citing that it was too expensive to run, and because they built it so quickly, it was unsafe. It did not have the guardrails in place to make sure that the system was only helpful and not actively harmful. In summary, LLMs have the potential to solve lots of exciting use cases, some of which we have covered today. But there are serious security and privacy concerns with LLM APIs and the models themselves. Bias and hallucinations are also a problem with LLMs that remain to be solved. And finally, there are very large costs incurred with the training of and inference with LLMs that we need to be cognizant of. Thank you for your time.